This video is the conclusion of linear relations about modeling and points of intersection. So it's important to be able to determine the rate of change, i.e. the slope, and the initial value, the y-intercept, in any of the four ways that we've talked about. Okay, so just a reminder that we can give you the scenario, if you like, or the linear relation in description in words by an equation, given a table, or given a graph. And we've kind of looked at all this. I just want to make sure that you are really clear on those equations. Okay, so the first one, a banquet hall rents their best ballroom for a fee of $250 plus $12.50 for every guest. So hopefully you can see from that that the rate of change or the slope is $12.50. It's $12.50 per guest. That's what that means. Okay, and the initial value, the flat fee, the fixed cost, really the y-intercept as well, is $250, right? So even if you have no guests at the ballroom, the cost is $250. And so the equation, hopefully you can see it's a partial variation, and the equation is y equals mx plus b. Our m is 1250 x, and then our b, our y-intercept initial value, is 250. Okay, what about the next one? Bobby runs at a speed of 10 kilometers per hour. Okay, so hopefully you can see that the rate of change is 10, right? In this case, the speed. And there's no initial value, right? Starts at 0. That means this is a direct variation, so the equation is just y equals mx, and it's simply y equals 10x. Okay, variables are number of hours, and the dependent variable is the distance. So let's try some now being given the equations, okay, as opposed to being given the words, right? So here, the cost of renting a snowblower, C in dollars, depends on the number of hours that the snowblower is rented. An equation that models this relationship is that. So this would be the same if I was using y equals mx plus b, just to get you really used to that idea. This would be 35x plus 22. Okay, the rate of change or the slope is the 35, and the initial value is the 22, right? So in words, it costs $22 to rent the snowblower, no matter how long you use it for, and then it's $35 per hour. Hopefully that idea and that concept, that scenario makes sense to you. Okay, one more. The number of breaths that a person can take in minutes can be modeled by this equation, B equals 80m. Again, in the form y equals mx, it would be y equals 80x. Hopefully you can see it's a direct variation. The rate of change is 80 breaths per minute, and the initial value, it's a direct variation, is 0. Okay, so you're just going to practice a couple of those and make sure you got that idea. Okay, so here's where we sort of put all the linear relations knowledge together, and we look at what's called point of intersection, which is also your first unit in all grade 10 math courses. So really important that we understand this idea. So here's the scenario given in words. Okay, your family wants to rent a car for the weekend. There's Cars R Us. They charge $60 per weekend for a car, plus 20 cents per kilometer. And then there's Travel With Us, and they just charge 50 cents per kilometer. So first things first, hopefully from those words, you can try to write an equation. Okay, so Cars R Us charges $60 per weekend. That's our initial value, our flat fee, our y-intercept, and 20 cents per kilometer. Partial variation, right? So we have y equals, we have 0.20 for 20 cents per kilometer, and plus the $60, right? And just to remind you, you're going to need this when you go to do your graph and your table. Our x represents the number of kilometers driven, and our y represents the total cost. We're going to do a table here for Cars R Us, and we're going to do a table here down below for Travel With Us. Okay, now Travel With Us, they just charge 50 cents per kilometer, right? No flat fee, no initial value, no y-intercept, direct variation, and so the equation is very simply 0.50x, okay? And you don't really need this little 0 right here, okay? But it's good to remind you that we're talking about 20 cents and 50 cents. Okay, so we're going to go ahead and create a table of values for both options. Now I've given you the exact scale that I want you to work with here. I want you to go from 0 to 500 kilometers, increments of 100. So 0, 100, 200, 300, 400, 500. Same thing over here. And very important when you're creating these table of values to always include the zero. Sometimes people forget that, but you want that zero because you want to be reminded we're talking about direct variation or partial variation. Now, pause the video and see if you can fill in the total costs by yourself, and then come back and see how you did, please. And just to remind you how to do this using this one particular value, you're going to take 200, you're going to put it in the spot of x, so you're going to do 200 times 0.2, and you get 40, and then you're going to add the 60, right? And so this value is 100 there. Keep going on your table. Okay, so check your table. How'd you do? If you have any questions, make sure to come see me in office hours and ask me about that. Okay, now we're going to graph both of these options on the same grid. And this is sometimes a little bit challenging because you have to come up with a scale. Okay, the x-axis should be pretty simple in terms of the number of kilometers, and the y-axis we need to go up to about 250, and we do need to be able to plot some nice points. So make sure that you can always plot at least 2 points for each one. Remember, you only need 2 points to make a line, so you need to make sure you can at least get 2 nice points for each line. Okay, so I've done some setup on my grid right here. Don't forget all your labels. Don't forget to use a ruler. On the bottom, it doesn't really matter what scale you use, but I went every 4 squares is 100. You really only need these points anyways. Now, the y-axis was a little more tricky. What I ended up doing was going up by 20s, so every square is 20, highlighting the key values. If you went up by 10, it wouldn't be so bad here. If you go up by 50, though, it does become a little bit difficult to plot some of the key points that you need. Okay, so I'm going to plot Cars R Us first. I'm going to do that in green. Okay, my first point is 060. My next point is 180. Okay, my next point is 200 and 100. And then I'm going to jump all the way to my last point because that's enough. I've got 500 and 160. And it should, remember, make a perfect straight line. If I grab my ruler here, and we have a perfect straight line. Okay, so that's Cars R Us. You want to label it or color code it. And now I'm going to do Travel With Us. Okay, so Travel With Us, remember, is a direct variation. It starts right at the origin. And then I have 150. Now that's not really a nice point with this scale, right? It would be sort of in between. So that's just what I call, like, I'm going to make that a little point. But my next point, 200, 100, that's a nice point. Okay, and then I'm going to go all the way to 400, 200, because that's a really nice point as well. 400, 200, and that's a really nice point. So what I kind of do with the non-nice points is sometimes just make little dots on my page. And again, you want to be using a ruler. You want to be really accurate with this. This is Travel With Us. Okay, now, the question, of course, is where's the point of intersection? Determine the number of kilometers where both companies will cost the same. And hopefully you can see that it's this point right here that is the point of intersection, the POI as we call it. And that point is 200, 100. Also can be seen in the table right here. Okay, the same, that's where they cost the same. So what does that mean? That means if driving 200 kilometers, right, both companies charge $100. Now, you might even remember doing questions where what advice would you give to people who are choosing these car rental companies, and then you sort of have to interpret on either side of the point of intersection. But here I'm going to try to actually focus you on the algebra in moving forward to grade 10. So I want to take a look at how we could actually find this point of intersection using our equations without having to make the graph, although we can easily do it on the graph as well. But I want to show you how to do it algebraically. Okay, so here's a reminder of the equations that we created based on the words. And one thing I just want to show you is that both of these things equal y equal the cost. So really, what I'm asking is when does this one equal this one? When are they the same, right? When does this equal this. Okay, so watch as I write it. When does cars are us, the cost for them, equal 0.50x, the cost for travel are with us? Okay, so let's go ahead and solve this equation. This is kind of considered solving by substitution because we're substituting one equation into the other or setting them both equal. This is what you learned at the beginning of grade 10. So let's follow our equation process. Let's put all the x's on the left and all the numbers on the right. So on the left, we're going to keep the 0.20x. We're going to subtract the 0.50x. And I'm going to move the add 60 from the left to the right. It's going to become a negative or a subtract 60. And then I'm going to do some simplifying. On the right, I still have the negative 60. On the left, I have 0.20 minus 0.50 equals negative 0.30x. Okay, solve for x. We're going to divide to the other side. It's negative 60 divided by negative 0.30. And we're going to get x equals 200. Okay, so that's the x value. And then we can easily get the y value by just using either one of the equations. So y equals 0.50 times x. So 0.50 times 200, which gives us 100. So therefore, the point of intersection is 200, 100, just like we found out on the previous page, but that gives you an idea of how you can look at your work algebraically and sort of try to move forward with this process. Okay, give it a try. Thanks.